Lesson 5.2, Solving Inequalities by Multiplication and Division. Our essential question today is what is different about solving a multiplication or division inequality? So what is different? You can say something that would make it different from solving an equation or an addition-subtraction type of inequality. So a couple of different things to think about. Our first question says, what do we have to remember about multiplication and division inequalities? And the answer to that question is, if you multiply or divide by a negative number, you must flip your inequality symbol around. You must flip your inequality symbol around. So I'm going to explain this a little bit. So if you multiply or divide by a negative number, you must flip your inequality symbol around. Okay, so I'm going to start out by writing a true inequality for you. So I know that the number 2 is less than the number 3. And then I want to show you what happens to our inequality if I multiply by a negative number on both sides. So if I take a negative number and I multiply on both sides by, say, negative 4, I would get negative 8 is less than negative 12. Now, if you think about negative numbers, negative 8 is certainly not less than negative 12. Negative 8 is closer to 0 on the number line. If I put 0 on my number line, this would be my negative 8. Negative 12 would be over here. So negative 12 is smaller. Negative 8 is larger. So what happened is when I multiplied by this negative number, it made my inequality not true anymore. It made my inequality false. So that's not okay. So that's why multiplying by a negative, we have to flip the symbol around to keep the inequality true, to keep it true, a true statement. The same thing happens if you divide both sides by a negative number. So if I started with two even numbers, like I could say 2 is less than 4, and then what if my action step was dividing by negative 2 on both sides? 2 divided by negative 2 is negative 1. 4 divided by negative 2 is negative 2. Again, negative 1 is not less than negative 2. Negative 1 is greater than negative 2. So to keep that inequality statement true, you have to flip your symbol. And that only happens when you multiply or divide by a negative number. Okay, so our first inequality to solve, it's just one step. To get the x by itself, I just need to divide by 5. That will cancel out my 5. Negative 20 divided by 5 is negative 4. Now because my action step involved dividing by a positive 5, I was dividing by a positive 5, I keep my greater than symbol. I was not dividing by a negative. The negative on the 20 does not affect our inequality's truth value. Okay, the next one. My action step, I need to divide both sides by negative 3. Because I'm dividing by a negative 3, I am going to flip my symbol. So because this is a negative number, I'm going to have to flip it. Negative divided by a negative is a positive. Now if I was going to graph this inequality, I would want my variable on the left. So this would have the same meaning. 4 is less than or equal to x. It means the exact same thing as x is greater than or equal to 4. The next example looks like a fraction. So that means that our variable has been divided by negative 2. The inverse of dividing is multiplying. So I multiply by negative 2. Because I'm multiplying by a negative number, in my action step, I flip my symbol. So x is greater than or equal to negative 22. Another example with the fraction. My action step on this one I'm going to multiply by 5 because x had been divided by 5. That is a positive number, so I do not have to flip my symbol. 5 times negative 8 is negative 40, so negative 40 is less than or equal to x. If I turn it so that the variable is on the left, which you don't have to do, but I recommend it, it's a great habit, keeping your variable on the left, especially if you need to graph. My solution would be x is greater than or equal to negative 40. Okay, fraction. Fraction problem. Fractions are something that we love to work with. So, if I have a fraction next to my letter, x, remember that we can solve this in one step or two. To solve it in one step, I multiply by the reciprocal. So I take that fraction and I flip it over. I flip it over and I multiply both sides. By doing that, I cancel out the entire fraction that was next to my variable. Now, because I'm multiplying by a negative number, it's a negative fraction, so that I'm multiplying by a negative number, I need to flip my symbol, and I'm going to put a 1 under my 10, and then multiply straight across. Negative 30 divided by negative 2 is positive 15. So x is greater than or equal to 15. So multiplying by a negative number, whether it's a whole number or a fraction, or multiplying by a negative number, not a whole number, sorry, an integer or a fraction, would mean you have to flip your symbol. Okay, a word problem. Define a variable, write an inequality, and solve this problem. So we need to have our numbers. We need to have variable, and we need to have an inequality symbol. And we probably need some operations, like math operations in there. So that would be all of the stuff that we're looking for in our inequality. So number or numbers, variable, operation, like add, subtract, multiply, divide, and then an inequality symbol. Something like that. Okay, so Luke needs at least $3,500 to buy the car that he wants. So he needs at least $3,500. If he earns $8.50 per hour at his job, how many hours will he need to work to buy the car? So he makes $8.50 per hour. He needs at least $3,500 to buy the car. Okay, so at least, to me, when I see the words at least, that is going to be one of our inequality symbols. If he needs at least $3,500, at the very least, that means that it would be greater than or equal to. He needs greater than or equal to $3,500 to buy the car. He makes $8.50 per hour at his job. So my number is $8.50. My operation is going to be multiplication. And my variable, I'm going to use h because it says how many hours will he need to work. So this is my inequality. $8.50 an hour or per hour means that you're multiplying the $8.50 by the h. Now, to solve this, we would need to divide by $8.50, divide by $8.50, and 3,500 divided by 850 comes out to 411.76, and then some more numbers after the decimal point. So, because this is a word problem, we want a word answer, so I'm going to say he has to work at least 412 hours, because if he works 411, he's not going to have enough money. So I'm going to say Luke needs to work at least 412 hours. have enough money for the car. Okay, so it's a little bit of common sense in a situation like this, that if he's earning $8.50 per hour, he has an hourly wage, he's probably not going to be paid for like 0.76 hours, so you would need to round it up to have enough money. Sometimes you have to round down, sometimes you have to round up. It just depends on the situation. Okay, one more word problem. So we need the same stuff to write our inequality again. So Jesse has more than 45 CDs. This is about 1/4 of the amount that Sue has. How many does Sue have? Okay, so Jesse has, so I'm going to think about this. Jessie, her CDs are about 1/4 the amount that Sue has. So Jesse's compared to Sue's. So Jessie, let's see, and we're trying to find Sue's CDs. So I'm going to use S for Sue. So Jessie has more than 45 CDs. More than would be greater than, so she has more than 45 CDs. This is about 1/4 of the amount that Sue has. So 1/4 of, so the word of means multiplication. So 1/4 of the amount Sue has. So I'm going to multiply those together. And we'll see if this makes sense. So Jessie has more than 45 CDs. This is about 1/4 of the amount Sue has. To solve this inequality, I would want to multiply by the reciprocal to cancel out my fraction, 1/4. And 45 times 4 is 180. So it looks like Sue has more than 180 CDs. We'll see if that makes sense. Sue has more than 180 CDs. So Jessie had more than 45. This is about 1/4 of the amount that Sue has. So if Jessie has 1/4 of the amount Sue has, Jessie has less. Like if you think about Jessie's, so like Jessie has 1/4 of Sue's. So we've got Sue's CDs, Jessie only has about 1/4. So my picture shows 1/4, and then Jessie has 45, so it should make sense that if each of these fourths were 45, Jessie has more than 45, well, Sue would have 45 times 4. So I believe my answer makes sense. You should be able to write a summary now. Make sure that you use complete sentences and answer our essential question.